Okay, I'll start again. Hey guys. Why is there always something that goes wrong? So today we're going to be looking at the LED clock. It's come a long way since we did that last stream where I got kind of annoyed because we'd soldered, I don't even know where that other one is. Is it somewhere around here? We'd soldered one, oh yeah, here it is. We'd soldered one with, God, you can't see that, can you? We'd soldered one with the LEDs around the wrong way. And that was depressing. So we're going to be looking at the one that now works, which is fantastic. So let's jump to the main cam where you can see the clock alongside the one that has the LEDs the wrong way around. And it is readable, to me at least. The camera has a really low dynamic range in that respect, so you can't really see it. But if I put this over the front of it, you can see it. I tried looking for some anti-static bags, but nothing. I couldn't find anything large enough or clear enough. They've all got labels on, unfortunately. So this is the best I can do. Now you can, in fact, maybe I can try and change the camera properties and lower that. Maybe contrast. Increase the contrast. No, unfortunately I can't do anything with it, but let's leave it at that, and then hopefully when I put the bag over the top it will be clearer. Well, it doesn't really matter, it's the same deal. Where is the chat? I can bring the chat up hopefully. There we go. Oh, there we are, and there's my face. Hello. Okay, so we're at the point now where we've got the clock. Even though you can't really see it, there's no way I can shield this properly. You can't really see it, it's a bit difficult. But we're going to talk about the code as well. Let me bring this over here so I can read the chat as well. I don't know how you guys found it so quickly, this stream. Honestly, I haven't advertised it, it's just a gone live thing. I'm just going to drink a bit more coffee. It does have a little something something inside it as well. Yeah, sorry about the audio. I was still in the setting up phase and I clicked the wrong button. I wanted to record it and then listen back to it, but unfortunately I just pressed the streaming button and then realized 2 seconds later, well, a little more than 2 seconds later. I'm not going to say hello to everyone because there's a lot of you in here, but thank you very much for joining me. I appreciate it. I recognize a lot of names here. I've got a freeze frame. Yeah, it's just coffee. That's all it is. William asks, where did I get the PCB manufactured? I got it from PCBs.io, but they've been bought out by another company, so I don't know if they're still good. I mean, I got my PCBs fine. They're now, the company's called Brighter Make or something like that. Anyway, I'm going to show you the code now, so let's jump to that. How do I do that? Desktop, there we go. Okay, so I'm using a lot of libraries here. All I'm doing is really programming the flow control, so the logic in program. Should we put the chat back up? Chat and no. Add video capture device. Add existing from there, and it's going to go full screen. Sorry, I'm going to shrink my face down. Isn't that weird? Whee, there we go. Tiny little head. Perfect. In fact, we could just probably do, let's make it the same size as the chat, just for anyone with OCD. So this is our code. I'm using several different libraries, and one is the RTC library. I finally soldered on the DS3231. Or might be 21, I can't remember. Hang on, I've got one here, so do I? No, I don't know where they are, but I'm using that real-time clock chip. And the great thing about that chip is that it doesn't require an external crystal, which is good. That means your part count is lower. So I'm using that to get the time. I'm using the TLC 5940 library to control that chip that's on board. That's the 16-channel PWM driver. We've got shifter, which is a really simple shift register library. So it just means I don't have to shift out my own bits, and I can interact with them in a human readable way, which is quite nice. And we've got our serial lines and stuff set for those for the shifter and stuff. We've got a couple of these longs assigned to previous millis. Now these are used for timing, and that's partly for the display, for changing the value of the number being displayed, but also we're going to be using it to flash those bits, those two little digits between the numbers, and that's going to show us the seconds passing. So every time it flashes, you'll know that a second's passed, because I don't have a seconds display on this clock. The audio is out of sync. Hang on, let me look at let me watch this. Oh, I can't watch the stream because then you'll hear all the audio. How out of sync is it? Is it a lot, or is it just a small amount? If it's not a lot, then I won't bother with it. But if it's a lot, then I'll try and change it. But I'll carry on with the description of the code. It's just like half a second off. Okay. All right, let's see if that's possible to change in the settings. Oh God, if I only knew how to do this. I'm sure oh yeah. Edit, advanced audio. So is it behind or ahead? Okay, is that closer? No, it's not, is it? Right, advanced audio properties. Am I ahead or behind? Ahead, okay. Let's change that to 150 milliseconds minus. Okay, is that better? I don't care now, that's enough. I've tried to do it, but if I mess around anymore, then it might go wrong. So, I'm looking at the wrong thing now, hang on. Let's just move that there, okay. So we've got the intervals here. These are our blink intervals. This one's the display update interval. I should have written display update. This one's our blink interval. That's going to be for those two little LEDs that are going to be in there. We've got various things here defining the number of TLC 5940s. We've got the number of registers. We have a string here, which I no longer need. I should have taken that out. So let's comment that out now, just in case we have to come back and put it back in. Row is a really important one, and I'll explain why. And what I hope to do is explain how the clock updates the display. How am I addressing those LEDs? Because while it is a matrix, it's not a matrix in the normal regard, I guess. I'm not addressing it in the same way, at least. And that's because I'm running the rows rather than columns. And then we've got setting our shifter thing. We've got a count here. Now this was just for testing, so that can also go. Actually, no, it can't, because I'm messing around with it in there. And then we have the row master. The row master is, let's just bring up the main display. So the row master is actually all of the LEDs running along the top there. God, it's really small when I put my finger next to it. So it's all of these LEDs. So if you look at the row master on here, you'll see we've got all zeros in here, but actually if the time were, what is it? It says 21:10. That's not accurate because that's just the time yesterday that I uploaded the last bit of code. So it's counting from then, but because it doesn't have a battery backup at the moment. So this would be 1 1 1 0 1 0 0 1 0 0 1 0. So it would be the top of the 2, then you'd have 1 1, and then the top of the 0 just there. So that's how it works. We're doing it in rows going down, and that's because of my shift register, which is on the other side of the board. Let's have a look at that again. So the shift register, which is over here, is driving those rows. It's allowing current to flow across here, and then the TLC 5940 is syncing that current. Okay, I tell you what is easier if I just do that. There you go. There's no lag anymore. It's unbelievable, isn't it? That was a simple fix. You don't need to see my face. So we've got the 74HC here, and it is driving those rows, and the TLC 5940 is syncing the current down the columns. And because we're only driving one row at a time, we're not really using a multiplex display. All we're doing is turning one row of LEDs on at a time. And this TLC 5940 is syncing all of the columns. So it's not really multiplexed. All we're doing is switching on a circuit one at a time. So a multiplexed array might have one LED on that row being turned on, and then it would go to the next row, and go to the next column, and the next one, and the next one, and the next one. So it's not the same as your normal multiplex display. In fact, the first project I ever did was a multiplexed project, which was a word clock, and that multiplexed LEDs in a grid fashion. So one LED would be lit at a time. But in this one, 16 LEDs can be lit at a time. So it's not the same. But it also means it makes it a lot faster, which is great. But we do run into issues with the TLC 5940. There's my face again. Let's get rid of that guy. No one wants to see him because he's a laggy guy. So we're using the TLC 5940, which introduces its own sort of timing issues. So you have to wait for all the bits to shift out to those 16 different inputs. They sync the current. Anyhow, we've got an array here straight from the example in the RTC library, and it just has the days of the week in here. We're not going to be using those. Eventually I'll code in some letters to display on those on the LEDs, and then we're keeping track of the minutes, the hours, the days, months, years, and the seconds. Now I don't need to keep track of the seconds, but I do need to keep track of the hours and the minutes, and I'll show you how I'm displaying those. So we have an array here for digits, which isn't being used at the moment, but it will be used for the animations that we're going to have. So at the moment, I did plan on having each digit individually arrayed, and then they would shift out to the columns, but that's not what's happening. So if you just think of this row master as the only data that is ever put on the display, that's an easier way of looking at it. And all it is for each row, this data is replaced, and then that row data is written. So it's just blanked out every single time. So we've got our numbers array. This is how I'm displaying the data. So the numbers array, you can see here, is actually just a replica of the LEDs. So if I jump to the main desktop again, you can see here each LED thing. Oh, you can actually see the display source of there, 2114. So each digit is 3 across and 5 down, and that's what we've got on the code. So we've got an array of 3 across and 5 down. And I don't know if you've ever worked with arrays, you'll find it's so frustrating when you go to assign the size of the array, because it's really counterintuitive. So I don't know, well, when you're working in these multi-dimensional arrays, it feels counterintuitive. So in a multi-dimensional array, in a single dimensional array rather, so just a normal array, you set the size of the array in a row, but this is actually the size of the array in a row, but with these individual arrays inside it, and then you set the size of that array, which is 5 elements, and then you've got 3 in the row of that thing. So it's a bit of a mind F. So that took me a little while to get my head around, because it feels like maths, you know, like it feels like too many numbers. So we're using, these are our numbers. So they start at 0, 1, and then we've got 2, if you can see that. It goes down here, here, here. So each 1 represents a digit that should be turned on. And then we've got 3, 4, 5, 6, 7, 8, and 9. And we don't have 10 because that's 1 and 0. And we have 2 functions here, well, 3, 4 functions. We've got one function that we're going to explain, and the rest are exactly the same, except for just different, it's associated on the display differently. So we have set digit 1. And so in this way, again, I'm not treating it as a matrix, I'm treating it as individual matrices, I guess. So set digit 1, all that does is write out the first row of the first digit to our row master. So we've got the first 3 digits in our row master array. That is this one here. This is the first 3 digits. That's digit 1. And so in set digit 1, this function just here, we're taking in a digit and we're taking in what row it is. So at what point the shift register is at. So whether it's powering up row 1, 2, 3, or 4, or 5. And then we're saying, well, because it's numbers, we're looking at what digit it is. We get that through the function. We look at the row, which is a global variable that we set in our loop. And then we look at the column. So we scan through the columns from 0 to 3, and then we put those into the row master here, and we increase the column in that for loop. So it's really simple. Each one of these digits is set in our loop. So that's a function that we'll see in a second when we get to the loop section. In the setup section, we've got serial here, but we're not really using it. It's just for debugging, but it's really useful to be able to see that your clock is set correctly and what the date is and everything. And you can use it to debug various statements. I've done the same thing when I realized I couldn't see anything on the display at all, and it turned out I was trying to print a null value to the display, and I hadn't realized, but it's useful for things like that. We've got the RTC begin stuff. That is straight out of the library. I haven't even removed the comments, so you can see that one's straight out of the library. This function here, all it does, this RTC adjust, is sets the date and time to the time that you uploaded the sketch, which is really useful because it means you can just upload your sketch and it sets the time. In fact, have I got it plugged in? I haven't got it plugged into the programmer, but I'll do that in a second and we'll set it up. So Marcus says, I really understand that it looks more simple this way, but in terms of memory management, I'd use bitwise constructed integers in an array. Well, I don't need to worry about memory management. If I compile this, hopefully I haven't just deleted something that I need, then I've chosen a chip which has far more memory than I'll ever use in something this simple. So I'm using 19% of the program storage and only 31% of the available RAM. So my chip is far powerful. It's got enough memory available so that I don't need to really skimp on code. I can make it readable and understandable and easily modifiable. But you're right, there's lots of ways to make this a bit lighter. And I'm not a genius at coding. I like it. I like program flow and control, and I like logic, but I'm not a genius. So really, what I'm doing is just achieving the goal. I'm not really making it perfect. But if you're working with something with less memory, then certainly trying a different approach would be good. The shift register library, for example, is a bit of a waste of time. If if you're happy to do it yourself, then you can save a lot of space by not using someone else's library. So we've got a function here called draw digits, and this is called every single loop, and all it does is set the TLC 5940, which is syncing the current for each row. It's looking at the row master, and that's all of those LEDs in the line, and then we've got a value called dimmer. So what TLC set does is it says the first pin, or the 0 pin, will be set as on or off, and it's timed by the dimmer value. So actually, if row master 0 is a 0 times by that dimmer value, it's going to be off, because 0 times any number is always 0. But if it's a 1, it's going to be on. And we set that dimmer value globally. So if I scroll to the top here, we have our dimmer value set as the maximum. So this is its PWM value. So it's 4095. So I can change that later on. If you remember, I had an LDR that I was going to use, and that LDR would change the dimmer value, and so change the brightness of the LEDs. So if I jump back down, and so that's all it does. If it's a 1, it turns it on by timesing it by the dimmer value. If it's 0, it turns it off, and so doesn't sync any current, it's a really simple way of doing it. So I don't have to have the dimmer value in the array, which makes the array size smaller because we're putting less in there. It's essentially a Boolean array. I think I might have set it up as an integer array. No, it is a Boolean array, so it's relatively lightweight. So that's all that function does. That's the one that tells the TLC 5940 what to do. But it doesn't do anything unless the 74HC595 is allowing current to flow through that row. All right, I'm going to pause for a second and look at the chat and also drink some coffee. And I've put my face back so you can enjoy the lag. Okay, I'm going to read some chat, because I don't think it's appropriate to reply to you unless I'm looking at you. Okay, can I start again, please? No, I'm going to ignore everything about lag because it's probably there, I know, but what can you do? And next time I'll sort it out properly. Weird Science, no, not Weird Science. Arjan for Games says, use a for loop, please. Do you mean for the TLC 5940 bit here? The answer is no, I won't use a for loop. I might eventually, but I wanted to set these individually and comment them out so that I could see what was coming on when. And I had some flicker issues, so I wanted to take some out and put some back in. I had issues with the row master line not filling all the way, and I found out what that was eventually, but I wouldn't have realized what it was if it was all in a for loop, because it would just put all of those LEDs on, and I only noticed errors in some rows, not others, and it wasn't the beginning or the end, so a for loop wasn't going to help me at that point, and I'll explain what the problem was. So the TLC 5940 is like a shift register. You send it data and it shifts it along to all of its 16 different inputs rather. And so the problem I had was that I wasn't giving it enough time to shift all of those bits in, or rather to adjust all of the PWM values on those inputs. If I'd done a for loop, I wouldn't have seen what the problem was, so I had to do it individually. And it doesn't matter that I've done it as individual things, it still takes the same amount of time. It's no different than having a for loop. But it means that I can take some out, individual ones if I want. I can take out row 5 and just see what that looks like. But you know, I'm sure you know that I'm very familiar with for loops and I know how they work and why you would use them. I just haven't in this case for a very specific reason. What else have we got? Simon says that needs a for loop. I think I've explained why I haven't used one for now. Was the for loop explanation not enough? Do you still think it needs a for loop? I think for testing, I don't think it should have a for loop because I was in danger of not shifting out the bits fast enough. So that's why it's like that. I get that it could be in a for loop. It would be easy. They all start 0 here. The next one's 1, 2, 3, 4, 5. I get that I could put it in a for loop. I've used for loops already. There's a for loop in something up here. So yeah, exactly. For loops are in here. And they're pretty customized for loops in terms of numbers. They don't start at 0. So I understand that they work. So moving further down, because I don't see any new comments that I can reply to, I don't think. So moving into the, in fact, let's get to my face now because I'm sick of the comments about lag. Okay, so in our for loop, you've got me having that on the brain. In our loop, this is where the code gets a bit messy because it's still in development. Gets a bit messy. It's already quite messy, but because I developed this board without putting it on a breadboard, so I didn't know how I was going to code it. And I just started by trying to light some LEDs. So you'll see remnants of code in here. In fact, remnants of the whole structure is essentially me desperately trying to light the first row of LEDs. So that's how it was built. So before you comment on how bad the code is, you'll understand if you think that all I did was just try to light some LEDs at the start. So we'll sort of tidy it up. Probably not today. We'll tidy it up, but for now it's working, counting that it's using the time from the RTC at the moment. So in our loop, we're starting off with current millis. So at the start of the loop, I want to know what time it is essentially, or how many millis it is essentially. And we've got just this thing to, it's the blink without loop example. And so all I'm doing here is bringing in our date time, setting our variables that we talked about before, so seconds, minutes, hours, days. The reason they've got W on the end is because actually day, hour and minute seem to be part of the function for date time, and I don't want to mess around with anything where it might overwrite a value or anything. So, and then it's exactly the same as the blink thing. So all we're doing there is for every time the current millis minus the previous millis is greater than or equal to the interval, which in the interval in this case is 1 second up here, or 1000 milliseconds. Every time that is met, that condition, where did it go? Ah, here it is. Then we're going to do all of this. We're going to check the time, we're going to set our variables, and we're going to say that dimmer equals 4095. That I was testing that I put a random value in because I wanted to see how it looked on the display, and we're increasing count. And I did that just because I was adding count to the display. We've got another bit here, which is the interval blink, which we're going to work on in a minute. And all that's going to do is set those 2 digits. Then we've got, in the loop, we've got our setting of the digits. We send this digit to the function, and what I'm doing here is taking the 2 values that I get for minutes and hours from the RTC, and I'm turning them into the smallest digit, essentially. So this one divides the number by 10, and then it would just give me the most significant number out of that. So that's what that does there, and this one just gives me the most significant small number. So that's essentially all of that. So it's minutes and hours. So minutes, first digit, second digit, third digit, fourth digit. And once we've done that, we're going to clear our TLC, which gets rid of what's on the display. And then we're going to update the TLC because we've just set everything. So we essentially shift everything out. So this while function was the big problem before. So if you remember, I had this this bit here where you all said put that in a loop, which was a great idea, putting that in a loop, but this is where I fell down with it. So this while TLC.update, I need to pause while the TLC 5940 updates all of its inputs so that they sync the current and whatever PWM value I set. I didn't have this before. I just updated the TLC 5940, and what that meant was that not all of the digits were getting shifted out, or they were getting what looked like corrupted. So that was the problem. We've got a delay of microseconds in here just for a bit of stability. Doesn't really need to be in there, but I've just left it in there. It's a very small period of time. And we've got our shifter set all high. This turns them all off. If you remember, they're PNP transistors. And then we're going to set the row low for whichever one we want to turn on. And row is set at the start of the loop as 0. And then if the row is less than 4, we'll increase it at the end. And so the next iteration will be row 1, the next one is row 2, 3, and so on, whatever. And that's the end. That's how it works. So it just loops through, loops through, loops through, loops through. Each row is the thing that's changing, and then the TLC 5940 is syncing current for whichever LED should be on. And that's done with this row master times the dimmer. So it's fairly simple. Not that you can really read it in this light. It's very visible to me, I have to say, but I think it will look nicer when there's a cover on this thing, which will be similar to this. It will be a sort of a translucent or semi-transparent bit of acrylic, which I've ordered some, so you'll still be able to see the bit that says crap clock on it, because it still is a crap clock. It's not like it's brilliant or anything. So let's plug in the programmer stuff, and we'll be able to just program it for the correct. Oops, daisy. Let's just unplug everything, and we'll plug in our programmer. The programmer in this case is an Arduino Uno. So we want ground in first. Actually, we'll do ground in last. And that is our reset pin. So put reset in there. Purple is pin 13, which is the last one. Then we have pin 12. So the Arduino Uno is programmed as an Arduino as ISP, and then that is pin 11, ground, and then we want power. No? Have I put something in the wrong way? Oh God, don't tell me there's going to be an issue here, because that will bug the hell out of me. Oh yeah, we do need to put pin 10 in as well. Sorry, I should have done this beforehand. Got a bit of a loose connection here, hang on. There we go, that's better. So if I just pop this in front there, you can sort of see that it's on. Let's upload this sketch. So what port are we on? We're on port 5. Program is Arduino as ISP. In fact, I'll show you this bit. So all I've got here is the Arduino as ISP. That's my programmer, my Arduino Uno. And we're on port 5, which is the Arduino Uno. And the board I've got is, I've just burnt the bootloader as it were an Uno, because it's an ATmega 328P on the board, so it's fine. And then we'll just go to Sketch, Upload using Programmer. And then I'll jump back to the main cam so that you can see the time, hopefully update to 21:27. It will take a second to update, so it should start up with zeros. Still flashing. And that, oh, hang on, did I, let's see if I, oh, of course, hang on a minute. What I need to do is reset the time. So there's capacitance in here. So the DS, it's on the back here, just there. The DS3231 is keeping its display running, unfortunately. It's keeping the memory, so it's keeping the time. So we need to just give it a second just to burn through that. In fact, I'm going to unplug the microcontroller, the Uno. Just give it a second to reset, because this function here, if you look at the desktop, this function, if RTC lost power, so there'll be a bit set in the RTC. If it's still got power, it will keep setting this bit. But if it's lost power, it will look to adjust, this function will look to adjust the date and time. So we'll just give it a second. Oh, Simon says 7 by 5 characters would have been so much nicer. Do you mean 7 LEDs by 5 across? It would have made the board quite a lot bigger, and I desperately wanted it to be pretty small. I didn't want it to be more than 100 millimeters across, which, do you know, I could have used smaller LEDs, however I would have struggled to solder those myself. Right, let's plug it back in, and hopefully it has lost the time. It appears to. So, good. It's lost its time. Now we can upload again. So I'm just going to Sketch, Upload using Programmer. And I haven't selected the right port. I have. And there we go. It's uploading now. Error uploading to, oh yeah, I've unplugged the power. So let's just upload that again. And I'll put this in front of it, and hopefully this is going to change. It sort of depends on my system time. Well, that isn't right. Okay. If it's lost power, how do I do that? How do I haven't got the reset pin broken out, which is very annoying. Do I? I'd have to check. Anyhow, we'll do it a different way. It's fine. We'll just set it ourselves. So 2017, if we go to the desktop, we can see that I can just set the time myself, and if I can just guess at what the time is, so it's 9:31 and 22 seconds, so I can change that to 3:23, 9, 31, not 31, let's go for 32. I think that's correct. Not 9, actually, we want it to be 21. Okay, let's try uploading that. And I'll put this in front of it so you can see. Still uploading. There we go, 9, 21, 29. What? What is going on? Let's have a look at some serial stuff, shall we? 21, 29. Why won't it let me set the clock? Oh, well, I've just figured it out. I did put 2012 there, you're right. I've just figured out what I've done wrong there. I've got it in the lost power loop still, and I don't want to do that because for some reason this circuit's holding quite a lot of capacitance, so it's not doing it. So let's just set it in. Let's just set it just there, and we'll just do this the once. But it does mean every time it reboots, it's going to be set to that time. But that's not a problem, and we'll change that to a 3, so it's actually the correct time in now. So if I upload using the programmer now, jump back to the main display. Sorry, I had a bit of a, oops. Bit of a stupid brain moment there. So we're at 21:33, which is accurate. So if you look at the desktop, oh, you can't see it on the desktop. It is 21:33 for me, at least. So yeah, it's easy to adjust the time. Eventually, I'll be doing that with a function with the buttons that are available. But for now, I'm just doing it with the upload. So let's move some stuff out of the way and let's solder those last 2 LEDs on, and then we'll mess around with a function to turn those on and off. Right, so I need to get rid of that and go to, that's my face. Wide, no, desktop, desktop. That's the one. Okay, we can move this other webcam out of the way, the thing it was sat on, and we'll just unplug everything from here. Oh, actually, it'll lose its time. So I probably should have plugged it back in. Oh, never mind. And let's pop it into the little holder. Make sure that I've got enough room for doing that. Right, so that should, does that look okay to you guys? Hopefully. Let's move my coffee out of the way because I don't want that there when I'm doing this soldering. Let's put some orange LEDs in for this, shall we? I think these are the orange ones. I'll just give it a quick little test with a multimeter. Where are the probes? There's one. Oh, come on now. I've got them all tangled up with webcam cables. Very annoying. And, oh God, there's the other one. Okay. Oh, that's all tangled up as well. Sorry, I wasn't very prepared. I should have done this earlier. Okay, so it's around, which way round is it? You can't see it, can you? Let's push it over there so you can see. not that way round. That way round. So it's an orange one. We're going to use orange for these. Do I remember which way round these LEDs go? No, I don't. So it was power to the left. Do you remember I had a lot of problems with this when we actually, yeah, power to the left. So, okay. Right, I bought myself a new pair of these pincer things. What are they called? They're tweezers, but are they something else? I think it might be forceps, possibly. All right, let's get the soldering iron ready. I've run out of small solder, not small solder, small diameter solder. So I only have about 10 centimeters of it left. So I'm gonna have to be very careful. Now I can barely see this board, so you'll have to forgive me if this looks terrible. I can't even see the end of the soldering iron, but pop a little blob onto each bit there. Hopefully that's okay. In fact, you can't really see this, can you? So let's move this down a touch. And I'll probably need to focus that camera. Hang on. This one. Properties, configure video. That looks like it's in focus, doesn't it? God, no, maybe not. Hang on. It's a little close, isn't it? We'll try that again. There we go, that'll do. Right. Soldering iron at the ready. LED at the ready. If I can pick up this thing. Don't turn it around the wrong way, David, because that would be a disaster at this point. Sugars, I've just done it. That's on relatively straight. That was quite difficult from here. And we need one more. So these little orange LEDs are on different rows. So actually I think they're on rows on their own. So it takes an inordinate amount of time to light these up. Right, still can't really see what I'm doing, so you'll have to forgive me if it looks terrible. They're not straight, are they? So let's push that one over a little bit. Look at that. No. Because I know you're probably all screaming at the screen, I'm not looking at overhead like you are. I'm looking at it from about 60 centimeters away, so I can't really see. I can see that they are not equal. That looks about right to me. Maybe this one's a touch wonky. Well, that's going to have to do. Now let's switch this around a little bit and we'll solder off those last 2 bits there. Let's they felt a little bit off actually there. The solder didn't really apply very well, so I'm just going to use a little bit of flux just to help it along. It's probably because the board's been sat out for a while and got a little bit of my finger oil on it, I guess. Someone's talking about the MSF time signal, I see. I've got an MSC receiver. I did a video on it a long time ago, and I've been wanting to use it in a proper project for a while, but I haven't gotten around to it. I just did it on a little LED display. LED? No, LCD display, I think. All right, I'm just going to take this away for a second and just have a close look, because I can't really see. That looks all right, actually. Let's just check they light up. Yeah, Simon and Maxine are talking about the radio time signal from the atomic clock. I can't remember where the broadcast station is now. Is it Cumbria? That's where it used to be, I think. So those work, and they should be the same way around as these ones. Whoops. So that they've got a nice nice color difference there. I like that. So without doing anything else, we should be able to just reprogram the microcontroller to turn those on. And I think I'll leave it this close for now. And I'll just plug this in. I know you can't see very much right now, but trust me when I tell you this is super exciting, me plugging these little cables in. It's not. We'll get there though. This bodge wire has become really annoying. I think I'm going to order some new boards because of this bodge wire. I don't like it. It's mainly because I don't have... Whoa, that's the wrong way around. Hopefully I just haven't blown anything there by plugging in power incorrectly. So hopefully you guys can see the 2 LEDs that should blink. I can't hold this in any other way. That's very annoying. What I'd really like to do is have it like that. Just stay there. Where's Blu-Tack when you need it? You can see those 2 LEDs though, right? They're right in the middle of the screen. So we'll be trying to now flash those. So if we jump to the desktop, let's see if we can sort that out. Right, I need my keyboard back now. I'll turn off the soldering iron. Incidentally, the soldering iron, it's connected to the same USB plug extension as my computer is. And every time I turn it on or off, I get that USB disconnected or reconnected noise every time. I assume it's a power surge thing. You'll also notice when I solder stuff, you might hear the microphone crackle, and that is the soldering iron coming in. It's sort of coupling with the microphone cable. Right, let's see some programming. Okay, so if I look at let's load up the schematic and then we can find out which rows these ones are on and which part they're sunk into. So I'll just load that up. Loading up Eagle. I don't want to download the new version, thank you. Sorry, bear with me. I should have loaded this up before the stream started. I've got a fair few projects in here now. So that is the one that I want to load up. No, it's not. this one. I have two versions. One I decided was terrible, and then I decided another one was better. There's not a huge amount of difference in here, but difference enough for me to dislike it. So we've got these two here. So let's zoom in a little bit. So that one is connected. Where is it syncing those two? Do you know, the schematic's the easiest place to see this, isn't it? Let's bring the schematic in. There we are. Those two LEDs here. Those are digits. Digits? What are they called? The little dots in between the digits. I don't really know. So those are the two that we'll be looking at, and they are sunk on input 16 on the TLC 5940, and they're on row 1, 2, 3, 4, 5, 6 and 7. So that's what we need to do. 6 and 7, we're going to set the row all to zeros, and then 1 on the end. So that's what we need to do. So we'll scroll down in our code. So we want to have a function to clear, I think, the row master. So let's copy this here, and we'll call our function clear row master. Actually, do we need to do that? We don't really. We just need an on and an off, don't we? So we don't need to, we can clear it and we can set the bits at the right time as well. They're called dots. Thanks, Simon. Okay, so let's call it something else. Set dots. Bots. I mean dots. And actually, what we want to do in here, if we want to know which dots we want to set on and off, and the reason for that is we've got a temperature sensor built in. So actually we might want to have it displayed 21 degrees or 21 point something degrees. So let's say we have do we want a Boolean or do we want an integer? So we've got, I guess there are 3 different states here. We've got both on, both off, or either one on. So that's 4 states. So let's have an integer, shall we? We'll call it dot state. We need to have 4 different variables, so we may as well have it like that. Or do we need to do that? We don't. We can still use a Boolean. We could just use 2 Booleans, can't we? So you can just write bool if you prefer. I prefer to write Boolean. So we'll have Boolean dot 1 and Boolean dot 2. So we have the 2 different ones, and we can set them on and off each one. We don't need to do all, oh no, we do need the column. So we want to set that as 0 to 12, not to 12 actually, to 16. And then we want to say row master numbers equals 0. So we're going to set everything to 0. And then we want to set row master let's just check what I'm doing here. So int rows, we didn't need to bring in rows there. So for each row we're doing those, but we only want to do it for some individual rows. So that is for row 4 and 5. And we want to set row master 16. Oh no, hang on, I can't do this because they're on the same column. So it's always going to be the same. So it literally only needs set dots Boolean. That is it. That's all we need. Boolean dot. So we'll set everything to 0 and we'll set number 16 to dot. So that's all we can do. And here we're going to have to set everything up to, so 7, is that right? So if row is less than 7, we'll increase that. So how many have we got? Let me check. So row starts at 0, 0, 1, 2, 3, 4, 5, 6. Oops. So if it is less than 6 is what I want actually. We'll increase it and carry on. And so we want to have, oh God, this is getting messy. So if row is greater than 4, no, hang on, 5. Okay. Not quite what I want to do. We'll figure out some better logic for this later on. Won't do it now because I haven't even thought about it before now. So the pressure is on with you guys telling me. So we want dots. Oh, what was it? Set dots, is that right? Set dots. So I'll copy that. And we need a Boolean in there as well. So set dots. We'll just go with true for both of these. And we're just going to, this is just going to turn them on. So we're not blinking them or anything. I just want to light up these LEDs and make sure it works. So let's see if that compiles. Hopefully it will. And it has. And I'm going to upload it to the programmer now. And hopefully this should just turn those LEDs on. That's all we want to achieve for just now. And then we'll look at blinking them in a second. Are you going to turn on? No. Okay, so there's something else programming wise that I've missed. It should go through all of the rows. Now let's check I haven't. So if the row is greater than 5, greater than 5? No. Yeah, no, greater than 5, do that, else do that. Let's have a think. Ah, here is the reason, and I commented these out on purpose. So let's just pop it back in there. And we don't need, do we need that? Row master. $15, and we'll just change that to say 15 as well. I forgot that it starts at 0, so it's less than 15, I++. That's right, I think. Okay, hopefully that's right. So we'll upload using Programmer again. I don't want to need to stop pressing that button. I don't want to make life difficult for myself with reversing the polarity. Plus you can't actually sync direction in the other way because the TLC 59400 can't source current. It can only sync it. Right, no, that did not light them up. So this is the problem, is I hate this thing. So rowmaster 15. Set 15 as that. Is it actually on 15? Let's double check. It's definitely on 15. I'll jump back to the code again. Well, I agree, Simon. Creating a test pattern would be great, but I would have to rip out all of the code I've already put in there. It's not like this is a really painful experience for you, I'm sure. You guys came to watch me struggling with something. No one watches the David Watts streams not to see some kind of freaking disaster. There's always something. Always something. Right, so we've got Romaster 15. Let's just set 14, 13 and 12 on as well. And then that should be all of them on. So we'll just set this to be 1, 1, 1, and 1. Sketch, upload using programmer, and we'll see what happens. Hey Julian, nice to have you here. You've joined at the right time where I'm struggling to light an LED, which is hilarious. No, they're still not on. Okay, so, oh, that's my face again. Jeez, Luke, I'm deleting that scene. Hang on a minute. Remove, there we go. It's not too much special coffee. I've only had 2. So we've got this TLC 5940 that's not behaving. And I should be lighting up these rows, but it's not working. Why is that? Let's see. So they're all on that row there. They're on 1, 2, 3, 4, 5. So actually that's 4. So 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. So 5 and 6, I want to, oh, there might, did I solder on? Yeah, they are. Just checking I soldered on transistors to those sections. That would be embarrassing, wouldn't it? The LEDs are just flickering because they're not flickering in real life, literally just because you're seeing it at a different angle and the webcam's weird. There's no real difference there. To my eyes at least. I have increased the loop by another 2 loops. So it will change the amount of time. Let's go back to the code and have a quick look. I'm not quite sure what's happening, but then there's always something. So we've got 11. So all I'm doing is setting those as on, and we are setting those rows, aren't we? So if row is less than 6, let's just set it as 7. So in our loop, shifting out the row to low. Let's just upload that again. I don't know whether it's just missing out the correct row. Let's jump back to the main. No, still not doing it. Oh, maybe they're wired in the... Have I soldered them the wrong way around? No, they are correct. That goes into... Did we miss out a resistor? Possibly. So there should be a 470 ohm resistor on the board. Where? So I'll jump back to the main cam so you can have a look. What I'm looking for is a 470 ohm resistor, which should be over here somewhere. Is that right? Let's check on the schematic. So we've got a 470 ohm resistor. Oh, it's on the top side of the board. No, it is there. So it's this one that controls that last row. I'm just going to measure it with my multimeter and see if I can read any voltage across it. You've always got to check the simple things. No, nothing at all. Where's the bottom row? There it is. What is that there? That is just a capacitor. Oops. Right, let's find out on our diagram what's going on. Yeah, a lot of people watching over my shoulder. Okay, so let's talk through the problem and maybe you guys can help me out. So if we look at our schematic, I'll jump to the desktop. This is our column of LEDs. Now I can already light all of these columns here, so all of those ones I can light. These other ones here aren't soldered in yet, apart from these two at the bottom. They've just soldered those in. Now they are on separate rows from the 74HC595. Those are connected to these transistors over here, and all of the components for those are soldered in. So it is connected to... No. Okay, so I'm glad I talked it through with you, because then I didn't realize what I've done, which I do now realize. So 74HC 6 and 7, I designed this board a bit differently. Now I tell you what, I need to go and nip and have a quick comfort break, but maybe you guys can figure it out. So I will be back in a minute. Just bear with me. Sorry about that. I had to, let's call it a comfort break. But I've just figured out what the problem was. I wonder if anyone in chat figured it out. The resistor is trying to read voltage on. 16 don't have any LEDs. Workshop don't think any transistors on those two lines. Yeah, Kev is correct. There are no transistors on those two lines. So have a look at my transistors. They're just here. And we can see it's 1, 2, 3, 4, and 5. And if we look at our lines here, 1, 2, 3, 4, and 5. But did I mess up? The answer is no, I didn't. I actually decided I would drive them differently, but I designed this circuit so long ago that I'd forgotten what I'd done. And I'm driving these directly from the 74HC595. So we have a logic problem. And if we look in our code again, we can see that the logic problem is that we drive them low, and that's because we're reversing that logic essentially. So we drive the PNP transistor low to turn it on, and that gives us a high on the output of the transistor. But when we drive that row low for our LEDs, they're turning them off. So we need to say when this row is 4 or 5. So if row is greater than 5, we want to set the row to high. So this is, I'll do this differently eventually, but I just want to be able to get it working. So we'll just change that to high, and hopefully that will work. So we'll upload that to our programmer, and that should work, hopefully. So I know that the 74HC595 can source something like 16 milliamps per pin. We're running these LEDs through a 470 ohm resistor, which should give us a very small amount in, well, it's not working. That's good, isn't it? Should give us a very small amount of current going through those LEDs. It should not be high, but it isn't working. So let's take out what do we do here? How frustrating. Right, so we are shifting it as high when the thing is greater than 5, which should turn one on. And if it's less than 7, row plus plus, that's correct. If the row is greater than 5, set dots true. So set dots does what again? So row 15 equals not dot 1. Is 1 the same as true? It isn't, is it? Not in this, you can't times true by the dimmer, so we have to have an int here. So we'll have to have int dot, and we'll come back to it when we try and figure out how to turn the individual dots on. So where's our set dots function? Set dots equals 1. Upload using programmer. Something should happen, I hope. So yeah, it's reversed logic essentially. The answer is no, it's still not working. I don't have an earlier version of this code with just stuff on here, so it's a bit difficult. Bugger off. Bugger off. That's your actual name. Brilliant. You didn't miss an awful lot because I failed at stuff, but yeah, 1 and true are different. You're right, Simon. I realized that. So if I set dots as 1, let's see what set dots does. Set dots does row master 15 equals that. Let's put this, let's set all of them to 1. And upload it again and see if I'm just doing row master 15 wrong. We'll see. I definitely haven't reversed the LEDs. They are the right way round, I think. Okay. All right, let's do something else. Let's set them as 4095. We're not even using the row master at this point, actually. I've just realized. We'll try this again. No. Okay, so what is going wrong? I'm going to jump back to the code so you can have a look what I'm doing. Oh, I can get rid of this be right back thing. There we go. Well, we can change the size. Edit, preferences, size 20. Maybe you can see that now. It's difficult to be able to scroll through all this stuff and have you guys see it. So row master is 16. This is all of our rows. We're only interested in this last one. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that is wrong. So there are 14 in there, and actually we need another one to get to 15 or the 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, giving us 16 long. And if I compile that, is it going to throw an error? No, that's right. So what happened there is it didn't have a value for the row master 16. So maybe that not having a default value was the problem. We'll find out. I'll just upload it again and see. No. Okay, so why? Why on earth? So we're updating, we're setting all as high. If the row is greater than 5, we're setting them as I'll tell you what I can do. Let's go back to the main cam, and I'm going to disconnect from the microcontroller for a little bit, and we're just going to poke around on the diode mode on our multimeter and see if we can light it up with the LED in series with those two bits. So it is power over here. So if I pop that here, and hopefully you'll be able to see the resistor I'm going to poke on just over here. So it does work. It is lighting up. So it is connected, and it should be connected to one of these over here. So if I switch around, I'll put my ground over here, which is what it should be, and we'll find out which pin it's connected to. So it's connected to, oh, I can't quite get a good connection. There we go. So it is connected to, oh, you can't see it, can you? I'm just going to get rid of chat for a second. It will come back. There we go. So if I poke that onto the ground of that, or the ground side of that resistor, and it should be the LED. Oh. Oh, you can see both of them there. They're flickering a little bit because I can't get a good connection here. There we go. You can see that that one's on. and the other one is on the other row just there. So it is connecting through, but this should be connected to one of the pins over here. So let's just check it's connected, and we'll just use continuity mode to do that. And we'll check it's connected to one of the pins of the TLC 5940, and that should be up here. In fact, let me just look at the board because I'll be able to see it properly. So the last row is connected to roughly the middle pin. So if I just do a continuity test from the resistor there to one of the pins over here, that pin there, so you can actually draw the line across, so you can see it's coming up here, going across to that pin there. So it is there, but it is not working, and why I'm not sure. I'm just going to check the continuity between the pad and between the chip itself. I'm not doing this on camera just because I've got to get it close up to my face so I can see which one it is. Yeah, it is connected, so I might need to break out a little bit of code just to go bare bones on this and make sure I'm doing it right. So let's plug it all back in, and we'll do it bare bones with the TLC and the 74HC595. So we're just going to light up that one row, and that's all we're going to do for this. So I'll just plug all this back in. Hopefully I've plugged them in the right way. I'm very used to it. Hello. Well, they appear to be lit. And the time is on. Did I... I don't know what happened there, but they are on now. So let's just try reprogramming it and taking those out. So we'll shift it all to low. Simon asked, do I have a scope? I do, but it's a huge old CRT scope, and it's not for moving around. So it is on. Why is it on? It actually shouldn't be. Well, that is concerning, isn't it? Now they're on, and I don't know why. I've broken electronics somehow. They shouldn't be on. If you look at the code, I've just switched it out, uploaded the program again, and I've switched it out to say low on each one of these things. So we'll bring back chat here. What has happened now? Oh, I think I know. No, that's not right. Let's just, we'll comment out some bits in here. And I'll set those as 0. Sketch, upload using programmer. The TLC should not sync current from these now. Okay, so that's worked. Let's jump back to the desktop and you can see what I've done. I've taken out TLC 15 and we've put it as 0. So I can put it as 1000. What did I mess around with in here? So if row equal is greater than 5, set dots 1, set dots 1 adds, that's what it is. Set dots 1 makes all of the rows 1. So it was working, we just did it stupidly. So let's go back to this. Row master times dimmer. Sketch, upload using programmer. Yeah, we need to put the set high. Oh, set all high, and then I set each individual one low. So yeah, you're right. That's what's happening here. So we want to set them all. We don't really want to set them all high, do we? Well, I guess we do. Oh no, we don't. So TLC clear, set all high. I don't really want to do, in fact, let's do set all high, set pin row. Was it 5 and 6, wasn't it? I think. Let's just double check in the schematic. I think it starts from 0, so it's 5 and 6. And they need to be set low. And if they're 5 and 6, we'll set them high. Okay, so upload using programmer. I should turn them off now, hopefully. Did I copy it without changing it? You're right, thank you. Is it 15? I think it's 14 actually, isn't it? Is it? No, because it starts from 0. So they have turned off, which is nice. So upload using programmer. Oh, please tell me it works this time. That would be amazing. So it's set 1 dot on. Look at that. Richard says he has no idea what's going on. I think there's probably a few people in chat that don't know what's going on. And the guy behind the camera doesn't really know what's going on either. So we've got 1 digit lit. Now the reason that would happen would be because why? Why would that happen? Why would it only be the 1? It should be both. So if row is greater than 5, so 0, 1, 2, 3, 4 is 5. So that should be when it's greater than 4. Excuse me. So should they both light now, hopefully? So no, just the 1. Okay, so if I jump to the desktop, we've only got 1 lighting now, and it's very difficult for me to understand why because of all the pressure you guys put on me here. So we've got set dots equals 1. Let's just check that function. We'll do it bit by bit. So set dots, row 15, it's always row 15, is 1 int dot. So we're just turning both of them on at the same time. And it's doing that regardless of the row. We don't need rows in here actually. I don't know why we've got that. Draw digits rows. No, we don't need it. Okay, that's fine. So number 15 times the dimmer. So what is writing over my thing on, what is it? 1, 2, 3, 4, 5. So row 5, is it? Let's have a look at the schematic again. So LED 81 and 82. So if we look at the board, only the bottom LED is lighting up, which is LED 82. So 81 is not lighting up, and 81 is on 0, 1, 2, 3, 4, 5, 6. So number 5 isn't lighting up for some reason. So let's have a look why. It'll be something to do with the So if it's greater than 5, set it to greater than 4. That's what we want it to be. Sorry if you're ahead of me in chat, because I know you guys can scream at the screen and tell me the answer, but I don't see it until I've already figured it out. So, let's just jump back before it comes on. There we are. I missed it. Okay. So both of them are on now. So that seems to be right. The logic works. And all of this code is messy as hell, but we'll sort that out eventually. So I'll sort of pare it down and pare it down and pare it down, and then we'll be able to sort of reduce everything down a bit. This if row is greater than 4 thing isn't going to work for me. I'm going to have to create something which does that properly. But in the meantime, we're going to mess around with the set dots thing so we can make those flash. Where is set dots? Just here. So let's have, so if row is greater than 4, let's just copy that. We'll just take that out for a second. And we sort of need a Boolean to tell us whether they're on or off, don't we? I mean, I could read the bit. Let's read the bit. So let's do an if row master equals 1, and we'll just take out set dots. And then we've reversed that logic. So, okay, so that should work. So in the blink interval, if the row is greater than 4, so that's if the current loop, because we go through the rows, so on the display rows, if the row is greater than 4, and if row master is 15, is 1, then we set that to 0, else we set it to 1, and then we reset our millis and the blink interval. So hopefully, if I've taken it out of here correctly, that's right. This is messy, I realise, but we'll sort it out later. Let's just upload that to the program and see what happens. So hopefully they should blink. I'm not quite sure how this is going to work with the delays that we already have in the loop, but it should at least blink. I don't think it's going to be perfect. Well, they're on. And they didn't come on straight away, but they're staying on. So set dots 0 isn't turning them off. Why is that? What does our set, dot. Sketch, upload using program, because we were just testing, we just put a 1 in the, we just put a 1 in here rather than dot. So while testing, I just wanted to make sure that I could turn it on. But now we want to know that they blink. So let's go back. I've changed it to dot. On, off, on, off, on, off. Yes. Okay. So they blink. That's exactly what I wanted them to do. They're not blinking very fast though. So that's blinking 1, 2, 1, 2, hang on, 1. About every 1 second, isn't it? So the on-off period, oh, I see. So they're on for longer than I want them to be. Let's change that to 250. Upload using programmer, because of course it'll go through the loop, turn them on, go through the loop again, turn them off. So let's change that to 250. So they should blink more quickly now, a bit more realistically. Oh, there's a weird bit of logic going on there, isn't there? So why is it doing that weird thing with not a regular flash? You see where it's got a double jump there. Let's try taking out this delay. Oh, do you know what I think that is? Let's we set all of them to high, we clear the TLC, we wait for it to update. Let's try uploading this code again. We're just gonna, I've taken out some of the delays, so hopefully it's hopefully it'll work. Wolfgang says that's a very complicated blinky sketch, and he's right, it is. It's because I'm trying to blink some LEDs which were a second thought. Oh, you can see now that it's flashing. That's why I put that delay microseconds in there for stability. So let's put that, we'll put this back in. So I've just taken out this delay. I'll pop it back in. I'm not sure why it is doing this double jump thing. What is it? What is it doing? So if the row is greater than 4, we'll set that as high, else we'll set that as low. Then when we come around again, we are shifting out all of the data before setting those pins low again. That is the issue, I think. So I think what I need to do is, before I clear the TLC, in fact, at the start of the loop, I should probably set those shifter pins low. No, not at the start of the loop. When we shift out data, I think. So we'll set them low here. No, that's wrong as well. It's a difficult thing to do, actually. Simon says use a value from the RTC to do the blinky, not the delay. I could do, but I want to use those blinking bits, those 2 dots, for other things, not just for blinking. I'd like to use them as just dots. So I want to just use that one function to control them, which is why I'm doing the delay. Just because I want to use a single function to control whether the dots are on or off, and we'll do that with just that single function saying should both dots be on, should one dot be on, top dot, bottom dot. Let's just, so if I set them as low, let's just try that. No, that's going to definitely ruin it. Okay, before they're set high, no. It's setting them all high, isn't it? That's the problem. I wonder if it's just as easy or just as quick to set everything but those as high. Yeah, I think it might be just as easy to do that. So let's do that. It's going to take the same amount of time, I would imagine. But this might not even be the issue, so we're just playing around to find out where the bottleneck is here. So 6. So we're going to set those as low. Actually, we're going to set them as high. So let's see if that actually does anything. Well, the thing about, who is it that says that? That's... Frank says you need a function that controls the blinking. You can turn that function on when you want it to be running. Yeah, I can do. I can just use a Boolean in here if I want to. I still would like to have that constantly running. I don't think it's an issue that it is running all the time. We want those low, don't we? So just turn those to low. Those two rows only control those two bits, those two LEDs. So let's upload that again. Oops, got a bit of a slash there. Let's just see if that was the problem. Oh, we don't want set all high actually. I wanted to take that out, didn't I? So we'll do that again. Upload using programmer. So the rows 0, 1, 2, 3 and 4, they should always be high. That's to stop the PNP transistor from turning on. And 5 and 6 aren't connected to a PNP transistor, so don't need to worry about it being high, but we need them to be low so they're not pulling any current in. Now, does that flashing look like it's, there it is. It did it again and again and again, and now it's going back to its normal loop. Am I just seeing this? Is it really there, a weird blink? Does that look regular to you? It looks like it's staying on longer, like it's going through the loop. I guess maybe it's the row loop. 1, 2, 3, 4, 5, 6. So there are 6 rows, 7 rows. 7 rows? Maybe I'm doing an extra row and I don't need to be. So 7 rows, while it's less than 7. So while it's less than 6 is what I should do. So, okay, I think I've figured out what the issue is here. So if we jump back to the code, right at the bottom of my loop, I'm setting what the next row should be that it's going to update. And I've set it as less than 7. I always do this. I get confused when you add a 0 into the number of items that you have that you need to iterate through. I always forget that 0 is actually one of them. So it should be 6, shouldn't it? So while the row is less than 6, we add another one on. And that gets us to our maximum of 7 rows. And we only have 7 if you look here. Start at 0, even though I didn't start at 0 here. 0, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7. So I was adding an extra row on there that I didn't need to, and it's shifting data into those arrays. So maybe that's the problem. So let's try uploading that and see if that fixes our problem. So let's have another look and see what happens. Whoops. I think I've just pulled a wire out. Let's just find out. Well, that brown one should be in there. Hang on a second. Right, I'm just going to plug these all back in again because I've just pulled them all out because I was making sure that it was right and it's not. So we've got a ground that goes there, we don't need that. And ground is there. Sorry about this, guys. That one goes there. So purple, orange, blue. Actually, brown, blue, orange, purple is what I meant. they go on there. I wish my camera was easier to move around, because then you guys could see what I'm doing here, but it's just not, unfortunately. All right. Ugh, I've done it wrong. Hang on a second. Bear with me a minute. I need to move stuff around on my desk. Sorry, I've just messed up all my cables and now I'm having to sort it out again. So it goes, pin 13 is purple, orange, blue, and I'll just not bother putting the brown in. Okay, hang on a second, let's just put the reset pin in and tools, sketchbook, upload using programmer. Ooh. Mayday. Whoops, a daisy. Yeah, you won't have seen that, but I just had the board resting on some solder there, so I'm gonna just unplug it and plug it back in again. And hopefully it will upload, because it just threw an error at me because it shorted itself out, or I shorted it out. Are you gonna work? Yeah, okay. So let's bring this back into where you can see it. Despite it being incredibly difficult to see at this angle, so sorry about that. Do I have anything to weigh it down with? Just to... Ah, there's a power bank here. Let's just stick a power bank on it so you can sort of see it a bit better. You heard sparks. It's probably something to do with the microphone, I imagine. So let's, we're going to upload this sketch. It didn't upload before because I just shorted out the microcontroller, so that was clever. So upload using programmer. We've got, so there are 7 rows. Are there 6 rows or hang on, how did you say? The rows start at 0, so 0, 1, 2, 3, 4, 5, 6. Yeah, as long as it's less than 6, it can increment that row value. It does start at 0, doesn't it? Let's just check. So row equals 0 at the start of in the setup function. I don't define it again, do I? No. And we don't specify what it is anywhere else. No. Okay, so that should be fine. So if I upload that using the programmer, jump back to the main cam, it should still work. Fingers crossed. Da, 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 moment of truth. On, off, on, off, on, ah. Okay. Oh my God, that's frustrating. Right, so it could easily be that there's a microsecond delay in the loop. Also, we're shifting out more bits on the shift register dependent on the row. So it might actually just take longer to turn all of those bits off rather than individually just reading the bits from an array. So it could be that. I'm not unhappy. It isn't working very well, I have to admit, but it is working. So what I wanted to do was flash the bits, so I'm happy enough with that. So I feel like we've succeeded at something, even though I'm just, well, just a complete idiot really. Let's desktop video capture device, is that still on? It is not on anymore. That's just my face now. Let's see if we can turn it on, because I think we might sign off for now. No battery power in that camera. Okay, well, we don't have a face cam anymore, so that's fine. So say goodbye to the LED clock. I think we're done. I'm going to read through chat for a second. I'm really happy you all could join me, and I appreciate all the help because, well, as you know, if you've ever watched a David Watts stream, you'll know that I end up effing things up an awful lot and using the F word if I've been drinking, but tonight I haven't been, so we're good on that standpoint. The display's looking really nice. Let's get that diffusing bit of plastic in here so you can have a look properly at what it looks like. I don't know if that displays well on the camera. I'll have a look at the stream myself. Not very well, and there's obviously some, oh, do you know what, I could probably change that in the settings. Let's just have a look at the thing. Properties, configure video, advanced settings, right light, auto, turn off, auto, white balance, turn off, exposure. I know, if I turn the exposure right down, you can actually see it writing through those LEDs. It's doing it very, very quickly, I have to admit. And that makes it more obvious with those things. So if I just turn up the exposure, take down the gain, we get rid of the flashing. But again, we're just looking at, you see my finger move, my thumb moving there. That shows you how quickly it is working. But the delay is the flicker is pretty minimal, even on a camera. So that's actually, I'm quite pleased. So if I just turn up that exposure again, and we'll turn down the brightness and increase the contrast somewhat. So there we go. It looks all right, doesn't it? My font's a bit weird. But that's just what I've decided to do. So you'll notice there's an LED missing off the 6, and I just chose to do it that way. Actually, it's slightly lit, and that will be, for some reason, I'm not quite sure. It's just because we're multiplexing through those very quickly. You can't see it with the naked eye, thankfully. Let's turn everything back onto auto. Save, done. Okay. Okie doke. Right, well, that is the crap clock finish for tonight, I think. If anyone's got any questions, now is the time to ask. There's a little emoticon thing that you can use that has a little question mark. So if you want to ask a question directly to me, do it now. Otherwise, we'll be leaving it here, I think. I'll just read back and see if I missed anything. Oh, Simon says now it's going from 0 to 7. It wasn't. I just put it back because I'd shorted out the controller when it was programming, and I didn't want you to think that it had already been 6. So I just put it back again. Yeah, it was going through 0 to 7 before I changed it to 6, and then I put it back again. Frank said, because the loop function never takes exactly the same time to run. And I think that's probably accurate. Or at least it's a reasonable explanation as to why it does that. Because yeah, when it runs those 2 bits, it's not shifting the same amount out to the TLC 5940. We're also setting a pin high rather than low, so maybe that takes longer. I'm not sure. There are lots of reasons why it might be different. So I might change it so it flashes on every second, maybe. So I don't remember who mentioned it, something about reading the time from the RTC. I could do that every time the second changes. I could blink it then, but I think it's always going to be slightly off. So we'll see. Maxine says your second blinker is almost as irregular as my multi-display LED clock in crazy mode. Well, it's not that irregular. It just has at the end of the loop of 0 to 7. In fact, it's not even at the end of the loop because it's going through very, very quickly. So there must be something that's happening. So current millis, previous millis, right, in the interval, previous millis equals that. Yeah, I think I've just sort of figured out what it is. So blink, the blink interval. So sometimes that happens during a time when it's not in the right row. And we had, I should have closed down the stream by now, but let's jump back and I'll just explain why I've just figured it out. So inside this interval loop, this if statement for the interval, we've got our interval blink, but we also have this if statement, if row is greater than 4. Now actually what happens if the interval triggers, this interval that we're looking for, what happens if that triggers when it's not on the correct row? Then we skip setting those dots. So what happens if it triggers when dots are already set to 0 or they're already set to 1? Then we get a longer off time or a longer on time. So I need to figure out why or how we can alter that, I guess, to have it always work. So I'll think about that. But that looks like it's probably the issue, is that sometimes that interval is going to happen when it's not on the right row, and so we won't be changing the those LEDs in the row master. That looks like it. Anyone else? Do you reckon that's the problem? In fact, what we could do is say if row master will only ever be 1 when it's on row 4 or above. So we don't even need this row here. And oh, look at that. Well, set dots equals 1. Yeah, the problem is if it sets it when it's on a lower row, then that's it's not really going to work, is it? So we might need to have a watcher so that whenever it gets around to that row, yeah, I might need to have a separate separate variable. Yeah, so I'm polling the RTC should be plenty fast enough. I just don't really want to rely on that for blinking. I want to be able to animate these LEDs, so I want to be able to find a way of doing it functionally. But I'll have a look at the RTC thing. It might well work out well. Larry says, or a pipe to a time server signal over an ESP8266. Yeah, I could use an ESP8266, but I haven't started designing boards for that yet, so I'm not really au fait with creating my own board for that yet. But I've bought some. I've got 4 of the ESP-12s to play around with, so I will eventually be making my own board. But for now, we're just working with this little low-powered DS3231 and the microcontroller that's on here. I don't know how much current it's drawing. I could hook it up to a multimeter and tell you. I don't know how much the voltage drop on this thing will be, but we can have a look. Let's unplug power. Oops, a daisy. Just pulling power out there. And I'll tell you before I go, because that'll be the last thing that I do, I imagine. What I could do with is a crocodile clip or 2. Or they might be alligator. I don't know what the difference is. I know the shape is slightly different. So let's throw that onto power. And that goes onto the ground of my multimeter. And we'll try powering it on. Hopefully you'll be able to see that it comes on. So with all of those LEDs lit, which is 1 row at a time, and microcontroller running, everything else on board running, including the DS3231 and the 748C595, we are pulling 35 milliamps, peaking at 37 milliamps. So I wonder if all those LEDs were off, how much we'd be drawing, but it's probably about 10 milliamps, 10, 15 milliamps for all of those LEDs that are on. So it's not low power, it's still a fair amount, but certainly okay. The idea was that this would only be on when you turned it on. So it has a circuit on the back here, which is not populated yet, just over here, where my thumb is, which has a switch just there. You press that switch, it would go on. It wouldn't have to be wired on the back, obviously, there'd be a button on the top, but it could be triggered by anything that was able to connect those two pins. But that's not implemented yet. Anyhow, I'm getting tired now because it's 11 o'clock in the evening. And I think that was the problem anyway. I shouldn't have been so tired when I did this. So thank you very much for watching, guys. I really appreciate you showing up. It's been fun, hasn't it? Fun and frustrating for you guys. Anyway, peace out all, and I will speak to you all soon. Goodbye.